So question 41 states, methanol is used in the production of many chemicals. Methanol is made by reacting carbon monoxide and hydrogen at high temperature and pressure. Okay, to start off this question, you have to make sure that the equation is balanced. So right here we have CO plus 2H2 equals CH2OH. So with this, you have to make sure it is balanced. So we do so by making sure that all the side elements equal each other. So we have 1C, 1 oxygen, and then 4 hydrogen. Right here, the 2 and the 2 make that 4. Right there and right there. Equal that 4. Then we go on the other side, just write down the elements and then write down how much of that element there is. So we have 1 carbon, 1 oxygen, and then we have 4 hydrogen. So we have this 3 hydrogen and 1 hydrogen right there, which make that 4. And then we have 1, that's equal to each other, 4, and then once you see everything's equal to each other, then that's how you know it's balanced. So we didn't have to add any coefficients to this problem. Part A asks us to find how many moles of each reactant are needed to produce 3.60 times 10 to the second grams of methanol. In this question, we're basically converting grams to moles of each reactant like how it says in the question. The reactants being CO and 2H2. We start off the equation by writing down the given amount of methanol they give us, which is 3.60 times 10 to the second power. And then we multiply that by 1 mole of methanol over the molar mass of methanol, which would be 32.05. Grams, of course. So then we multiply that by the mole ratio, which would be 1 mole of CO over 1 mole of methanol. So we do this 1-to-1 ratio because there's no coefficients in front of CO and there's no coefficients for methanol. And once we multiply and do the full equation, we get 11.2 moles of CO. Then we continue on. We write down the given again, and then we do basically the first 2 steps, which is writing down the given and then writing down the mole, then the molar mass of methanol. However, the mole ratio is different. So in this case, we have 2 moles of H2 over 1 mole of methanol because hydrogen has the coefficient of 2 in front of it. So then once we complete the question, we have 22.5 moles of hydrogen. So part B asks us to calculate the number of grams of each reactant needed to produce 4.00 moles of methanol. So we're converting moles to grams in this question. So we start off the question by writing off the given, which would be 4.00 moles of methanol, then writing the mole ratio of 1 mole of CO over 1 mole of methanol. Then we multiply that over the molar mass of CO, which is 28.101, over 1 mole of CO. And when you multiply that, you get 112 grams of CO. Continue on with the second part, which is writing down the given as well. Then multiplying that by 2 moles of hydrogen over 1 mole of methanol because of the coefficients hydrogen has. Then you multiply that by the mole ratio of hydrogen, which is 2.02 over 1 mole of hydrogen. And once you multiply that, you get 16.1 grams of H2. Part C asks us to find how many grams of hydrogen are necessary to react with 2.85 moles of CO. So similar to part B, we're converting moles to grams. So we start this off by, again, as the ones before, writing down the given, which in this case is 2.85 moles of CO, then multiplying it by 2 moles of H2 over 1 mole of CO, which is the mole ratio. Then we multiply that by the molar mass of hydrogen, which is 2.02 grams, over 1 mole. Then we continue on by multiplying it to get 11.5 grams of hydrogen.